Hello, dear students. I'm going to show you how to do the study guide. All right, so let's take a look at the first one. This one, we're trying to find the missing length. So let's find out which ones are corresponding. First, this is our missing side, it has a question mark. We put the X. This corresponds to this, right? Those are the long sides. So we can go X over 28 equals, and then the short sides, 9 over 12. We're going to cross multiply. 12x is going to equal to 28 times 9. 28 times 9, 28 times 9 is 252. So we're going to have 12x equals 252. Divide both sides by 12 because we want the x by itself. X is going to be, and let's see if 252 divided by 12, 252 divided by 12, and that is indeed 21. So our answer is 21. That was what the answer key gave us, so we're good. Let's look at number 2. Okay, so why don't I take a look at the C? Our first letter is C. Doesn't look good. Is there a highlighter? It's all right. I'll just underline it. So this C, right, and the R correspond. So the C and the R, and then we'll use green for the D. The D and the Q have to correspond, D and Q. And then the E and the P. E and P. So now let's take a look. First, we have the X. That's DE, green to blue. Where's our green to blue? Well, that's QP. That's QP. So the X corresponds to the 14. X over 14 equals. And then what else do we have? We have DC, which is the 99. Green, pinkish, I guess, to the 11. That's also green to the pinkish. So we got 99 over 11. We're going to cross multiply. 11x equals 99 times 14. Let's do that. 99 times 14. 1386. What's next? Divide both sides by 11. Whatever number is next to that letter, right? Next to the x was an 11, so that's why we're dividing by 11. X is going to be 1386 divided by 11. I can actually just divide, but let's try 1386 divided by 11. 1386 divided by 11. 126. Is that our answer? Yep, it matches. 126. Next to Pythagorean theorem, right? So the hypotenuse C is always longest side across from the 90. So that's our C. So A squared plus B squared equals C squared. So we can have this as A and this as B. So we'll go x squared plus 12.3 squared equals 14.1 squared. X squared plus, remember 12.3 squared means 12.3 times 12.3. So I'll go 12.3 squared, that's 151.29. Equals 14.1 squared. Mm, 14.1 squared. Oh, whoops. Careful. Squared, 198.81. 198.81. All right, we want that x squared by itself, so we're going to subtract from both sides, minus 151.29. X squared is going to be 198.81. Oh, we're just subtracting these two. So this number that minus, and I'm going to copy paste this one. 47.52. 47.52. And then to get rid of that squared, we take the square root. That's the opposite. Sorry, it's not that clean, my writing. 47.52. So we're going to take the square root of 47.52. This is why I like the Desmos calculator, because it has all the symbols nice and neat. 6.9. So x is 6.9 inches, which matches our answer. The next one, so let me just let me box this off. All right, same thing. What's the longest side? Well, farthest from the 90, that's our hypotenuse, the C. And then the other two are going to be A and B. So we're going to go 5.7 squared plus 4.2 squared equals x squared. Okay, let's do 5.7 squared. 5.7 squared, 32.49. 32.49 plus 4.2 squared. 4.2 squared, 17.64. 17.64 equals x squared. Then let's add those two numbers together. 32.49 plus 17.64. That's 50.13. Then we're going to take square root. And then what is that? X square root of 50.13. 7.1, is that right? Yep, that's good. 7.1 meters. Okay. Next, state if the triangles in each pair are similar. If so, complete the similarity statement. Yes, they are similar. It's going to be, look, so what's the biggest one here? 55, 35, or 50? Well, 55 is the biggest on the top, and then 11 is the biggest on the bottom, right? So if you go 55 over 11, that's going to be 5. Then the next biggest is the 50 and the 10. If you divide those two, you're going to get 5. And then 35 and 7, those are the smallest. If you divide those, you're going to get 5. So they have a common ratio. All these, when you compare two numbers like the 55 and 11, that's a ratio, right? You divide it, you get 5. Same with the 50 over 10, 35 over 7. Getting the same number means that they must be similar because they got the same zoom factor. Okay. Yeah, okay, so next it says complete the similarity statement, right? So that's this bottom part. So triangle, use green. I'll use green. So L, actually, let me erase this stuff so it's not so messy. And I can start over with my colors. Okay, let's see. LMN. All right, why don't I highlight these different colors? So L is this one. And then M is this one. Green, and then I'll use blue. And is that one, right? Okay, so we're trying to figure out what is the order that we should go to. So LM is pink green. LM is pink green. So I'll just start with the pink since L is the pink. So that's the 50. Now for that one, I have to look at what is the like size, right? So 50 is between 35 and 55. So that's the middle size. If I look at the bottom one, the 10 is going to be the one that is between the 7 and the 11. So 50 and 11 are going to be corresponding. And this is M to N, green to blue. So I'm going to use green, this one. For that 35, that's the smallest one. So the smallest one is the 7, right? So that means we're going to have to follow this order, Q to R, and then R to S. So it's based on the size. And that's why our final answer is going to be similar to triangle QRS, as it says up here. So yes, they're similar. On the test, I think this question you might just have to write the similarity statement, which is that bottom part. Also, if you wanted to figure out what's the shortcut here, well, look at that. There's 3, you're comparing 3 sides, right? They don't give you any angles, so it would be side, 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 similarity. Okay, polygons in each pair are similar, find the zoom factor. Assume figure on the left is original. Okay, so if this one is the original, this one is the new, right? Zoom factor is always new over old. So it would be like this 48 over 40. What's 48 over 40? Let's check it out. 48 over 40, 1.2. We can double check 18 over 15, the short sides. Let's check out that zoom factor. 18 over 15, 1.2, good. So look, just to remind you what the zoom factor means, if we took the 40, right? I'm gonna highlight in pink right now. This 40, and we multiply by 1.2, we should get the 48. If we multiply by 1.2, let's check that out. 40 times 1.2. Yep, we got 48. See, so zoom factor is the number that you multiply all the sides by to dilate it, make it bigger or smaller. Okay, now we just have some flow charts left. Okay, remember there's like a few different shortcuts, SAS similarity, AA similarity, or SSS similarity. So if these if you can find that, if any of these three conditions are met, then the triangles are similar. Okay, so the first one, we're gonna see, oh yeah, what is the 60? I'm gonna ask you this, what's the 60? Is that a side or angle? I hope you said side. If the number is outside the triangle and in the middle of one of the sides, that's a side. So that's a side. That's a side. What about the 63? Well, that's inside. It has also the little circle, that means degrees, angle, and then that 84 is also on the outside in the middle of the side, so that's a side. The 110, that's a side. 63, that's an angle. 154, that's a side. So we're going to be looking at SAS similarity. But then of course the conditions have to be met, right? So let's see if they are met. But my guess at this point, you should be guessing, hey, I think it could be SAS. So the first thing we're going to do, let's look at the biggest side. Okay, that's 84. That's big, right? 84 is bigger than 60, and then 154 is bigger than 110. So I'm going to just try 154 divided by 84, and let's see what I get. 154 divided by 84, 1.83, repeating. Okay, now the A part, are the angles the same? Let's look. This 63, is that the same as the other angle they give us? Yes, they are both 63. So I can write measure of angle K is equal to measure of angle K. So in this example, they gave us the same letter, so we just use the same letter. If this said, like, if this was a B, then you would use a B over here. But that's not what happened. So let's get rid of that. Okay. What's next? Oh yeah. Also, really important for SAS, remember that the angle has to be between. So if they gave you, let's say they did not give you that 63 and they gave you a 60, let's say it was even a 63, it was the same number, but it was not between the two sides, then SAS would not work. You could not use this. Okay, then you would say not enough info or not similar. Probably not enough info. Okay. But that's not what's happening here. So let's finish this up. Let's take a look at the small sides now. The small side was a 60, 110. Let's divide 110 divided by 60 equals, and to be honest, that writing is a little bad, so let me fix that, even though this is taking me time. 110 over 60. Let's see if we get the same number. Yes, we did. 1.83 repeating. So if these two numbers were different, then we would say that they're not similar. If they did not both equal 1.83, they would not be similar, but they are, so we're good. Last part, triangle KLM. We do think they're similar. Don't forget your arrows and the arrowheads. K to L to M, that's the 63 to the big side, and this way, and then this way. So you see how the L to M is like blank? There's no number. So we're going to do the same on the smaller triangle. K to R, and then R to S. So triangle K, R, S. And don't forget the last part. Yes, this is similar because SAS similarity. All right, we're almost there, almost there. Okay. So another condition is if we got two pairs of angles that are the same, then we know, yes, that the triangles are similar. Now, is this true here? Well, I see a 94, and that is the same as this 94. I see a 30, that's the same as this 30. Okay, but this time we're not going to divide them. Remember, we only divide when they're sides, not when they're angles. When they're angles, we just have to say that they're the same. So we need just two bubbles here. Reason being, all triangles add to 180. So if two angles are the same, the third one must also be the same. If they're the same size, then they have to have the same angles. So we're going to do measure of angle B is equal to measure of angle S, right? That's the 30 degrees. And then measure of angle C equals measure of angle T. I'm going to go triangle TSR, similar to triangle. So if we go T to S, we're going blue to pink, and then we go that way. So we're going to go the same thing, C to D, and then blue to pink, and then the other way. So it's going to be triangle CDE. And this is called, oh yeah, don't forget the arrows. And this is angle similarity. Number 9. Okay, look, they do not give us any angles. No numbers inside the triangle, only the sides. So that means it's got to be SSS. But remember, only if the numbers equal. Like after you divide it, only if all the numbers are equal, then it's SSS. So biggest, 104 is the biggest, and 40 is the biggest. 104 divided by 40 equals 2.6. Next biggest, 91 and 35, right? 91 over 35, that's the middle size. Once again, we got 2.6. It's looking good. Last, 52 over 20. over 20, let's see. 2.6, okay. So do we have a common ratio? You should say yes, because they're all 2.6. All the ratios are the same. And we're going to put triangle, LMN, similar to triangle. So L to M, and then M to N. So that's the smallest one, then the middle one. right? So then the smallest one was AB to the middle one was B to C. So ABC. ABC. And this is SSS similarity. Ah, man. And the arrows. Arrows. Okay. Last one. I know you haven't really seen this before because we didn't look at circles, but it should be pretty straightforward. The line from the middle part of the circle to the very edge, that's called a radius. And then, so the radius here is 12 on the big one and 6 on the small one. So to find the zoom factor, we're just going to divide 12 over 6 because it says left is the original. So that means right is the new over original or old. That's going to give us 2, right? So hopefully this recorded because I did this in one take. And, study this and you will do great on your final, I hope. You just have to study it. We went over all of this. Make sure that you can do all the problems without looking at the answer key. Okay, that's the important part. All right, see you soon. Over and out.